Hello friends, welcome back to our channel STM Mechatronics. So in this tutorial, we will see the actual output of our code that we have built in the previous video. So in previous video, we have seen how to configure the timer, then how to enable the peripheral clock of the timer. We have configured the timer 2. We have configured the ARR auto reload register to generate a 5-second delay, and we have configured the prescaler according to that. And we have initially loaded the count value at 0, and then we have enabled the timer. So by default we have used the reset values of the controller. So we are using the internal clock and we are using the upcounting mode. These two configurations are set by default. So this way we have configured our timer to generate a 5-second delay. So in last video, I'll just scroll through the whole code. So I'll scroll through the whole code. So here in main.c you can see we have defined the RCC base address, then RCC AHB1 address, RCC APB2 ENR address, and RCC APB1 ENR. Then we have defined the bit positions. So each register in STM32F401C6 controller is of 32 bits. That's why 32 bit positions. And in main.c, like we have taken one RCC AHB1 ENR. So here we have enabled the peripheral clock for GPIO-C. So in this tutorial, what we are going to do is we are going to toggle the LED which is connected to PC13, that is an onboard LED. So this is my STM controller, and this blinking LED that you can see, it is connected to PC13, port C, pin 13. So currently it is blinking by 500 millisecond delay. We'll generate or will increase that delay, we will decrease that delay, we will see the behavior. So if you decrease the delay to 250 microseconds, the LED should toggle much faster. If you increase the delay by 1 second or by 5 seconds, the LED should toggle slower. But for now, to do that, like we have to use GPIO-C. In order to use the GPIO-C, we have to enable the peripheral clock of GPIO-C. That we have done over here. We have enabled the timer peripheral clock. Then we have taken two structure pointers, one for GPIO structure, one GPIO regdef structure, and one for timer regdef structures. Now this GPIO regdef structure, it consists of configuration registers for GPIO peripheral, all the configuration registers for GPIO peripheral. And this timer regdef, this consists all the registers which are necessary to configure the timer peripheral. Now an onboard LED is connected to PC13, so we have to configure GPIO 13 in output mode. Then we have to enable the internal pull-up, and we are using that PC13 in output push-pull mode. So this configuration we have done over here. Now how to configure the GPIO in push-pull mode or output mode, that we have seen in our earlier videos. You can refer to those videos. But the basic idea is GPIO-C, we have to use the mode registers to configure it in output mode, and we are using pin 13 multiplied by 2 because 2 configuration bits are used for one port pin, so that's why multiplied by 2. Then here we are configuring the GPIO PC13 in output push-pull mode. To configure the pin in push-pull mode, we have to write 0. So what we are doing is we are setting it to pin 13, we are setting 1 to pin 13, and we are taking the invert of it. By using this, we are clearing the PC13 bit. And here when we set the pull-up pull-down registers, here we are setting the internal pull-up. This configuration we have seen in our earlier video. So in order to generate a 5-second delay, we have taken a prescaler of 8000 minus 1. So our internal RC clock is of 8 MHz. So 8 MHz divided by 8000, it will generate a clock of 1 kHz. Then with a clock of 1 kHz, in order to generate a 5-second delay, we have to load a value of 5000, and we are using an up counter, so the initial value will be 0. Now we have enabled the timer. So whenever the timer overflows the value of 5000, whenever the count register value reaches the value of 5000, it will generate an update event. So this update event will be set in SR register, status register, UIF. Now these bit positions we have already declared in the timer.h file. So timer x SR UIF, it is on bit number 0. So that we have done. So here what we are doing is we are waiting till the time the UIF bit is set. It means like till the time UIF bit is equals to 0, we are waiting over here. Once the bit is set, we are coming out of this while loop and we are going to the next instruction. The next instruction is clearing the UIF bit. So we are clearing the UIF bit so that we can monitor, or we can precisely monitor the next update event. Once this bit is cleared, what we are going is we are going to the next line. Here what we are doing is we are toggling the bit value. So GPIC output data register bit value is shifted by 13. Now if the bit value is equals to 0, we are setting it. If the bit value is equals to 1, we are resetting it. So this way what we are doing is we are simply toggling the bit value and then we are shifting it by 13 times, thus giving it to the output data register, thus toggling the LED. So this value in first iteration it will be 0. So 0 will be returned to bit number 13 of output data register, thus turning off the LED. Then the bit value will be set to 1. Then 1 will be shifted by 13 times, thus setting the LED, thus turning on the LED. So this way we are resetting the LED. Now we will build the code. Now what we are going to do is we will open the ST-Link utility. Then before clicking this connect to target, we have to press this power button on the board. Then click on this connect to target, release the power button and then release this connect to target. So over here you can see that our device family is STM32F401. Then flash size is 512 KB. Flash ID is this. So I'll program. We have created our hex file. Load the hex file. Okay. Now you can see that after every 5 seconds our LED will toggle. So LED becomes off, on, off, on, off, on. So after every 5 seconds the LED toggles. Now we will decrease the delay. We will make it to 500 milliseconds. So how the calculations are done, that I have already covered in the previous video. You can see that video. Now I have built the code. I'll load the code. Now this time LED will blink faster. So you can see that our LED is toggling very fast. Now in order to our human eye can watch up to 300 milliseconds. So what we'll do is we'll simply put it as 200. You can see that our LED is toggling very fast. So this way timer can be used to generate a precise delays. So this is it for this video. If you like this video, if you like my explanation, please give it a like, share with your friends, and thanks for watching this video. We will see you in the next video.